This and this will give you the same answer. Exactly the same. So whether you like to do it this way or this way, you can kind of play around with that and see which way you like. Now bx is going to be the x component of b. You can use the 20 degrees here, you see. You can say 35 cos 20 Now notice there, I only used the 20, the missing little piece. What would be another way to calculate that? If I wanted to do the actual angle of vector b, what would that be? This whole thing, right? 340 degrees. So I could have done 35 cos 340. Or another thing I could have done is, remember the original angle the problem gave me is the 70 degrees, right? This one was 70. So imagine, let me just rewrite it here. It was something like this, 35, and then they gave us this angle was 70. So I could have said the x component of the vector b is what? 35 times what? Sine of 70. The x component can be the sine of the angle if the angle is measured with respect to the y-axis, right? Now you can check with your calculator. All three of this will give you the same answer. Cos 20 is the same as the cos 340, which is the same as sine of 70. They're all the same. Okay? So that's the x component of the vector b. The cx, we don't know. That's what we're solving for. And now that's equal to dx, which is where the car is going to end up, which is 45 degrees, right? So the vector d looks like this. Southeast is 45 degrees, and the vector d has a magnitude of 10. And so dx is going to be 10 cos 45, right? It's positive. Okay? So now put that all into the calculator. Tell me what you get for cx. .14 miles. Now, the picture predicts that it's going to be positive, right? The vector c points this way. The x component is positive, and the y component of the vector c should be negative, down, you see? Okay, now we could do the y component. So that one is going to be what? The y component of the vector A is 60 sine of 40, right? Or you could have done sine of 140. It's the same because it's positive. It's in the second quadrant. And by is going to be negative going down. So what should that be? There's, again, a couple different versions of how to do it, but give me one of them. Don't be afraid of being wrong. That's the way you learn. Negative 35 sine of 20. Yes, exactly. So that's right. Or what would have been another version? 35 times sine of what? Sine of 340, right? The actual angle, the whole thing. Okay, now cy is what we don't know. And then dy is going to be that's the y component of the vector d, which is negative 10 sine of 45. Or you could have done what? 10 sine of what? Starts with 3. 3 and then what? 315, exactly. 10 sine of 315. Okay, so now solve for cy. Negative 37.67 miles. So now remember the question said how far and in which direction should the car go? So you go magnitude of c is square root of cx squared plus cy squared. So this squared plus that squared square root, what you get for the total distance that the car should go. And the angle cy over cx, right? Tan inverse of that. Now, it probably originally gives you negative, right? Negative 59.11. But then, you don't want to leave it that way. You want to be able to explain what that means. Now, if this negative, this is the angle that it's giving you right here, negative 59.11 degrees. So in terms of east-south, how would we word that? This is east, right here. 59.11 degrees, what is that? South of east, yeah. That's the final answer. So the car needs to go 39.23 miles at 59.11 degrees south of east to get to his final destination. Okay, now let's do the part B. What's the average speed of the car in stage 1? So this is going to be similar to that chapter 2 problem. You take the distance divided by the time. What was the time in the first stage? 3/5, was it? (100 miles an hour). Average speed in second stage is 35 over 5, what was it? 12th. That's going to be 84 miles per hour. And then average speed total